To illustrate the application and interpretation of the fixed effects model, we will use a subset of the famous Grunfeld investment data. We will estimate the fixed effects model using the LSDV approach as well as the within estimator. Moreover, we will discuss the packages and commands in R and Stata that can be used to estimate LSDV model, one-way and two-way fixed effects. The Grunfeld panel data that we will use consists of 200 observations. It has data on 10 U.S. firms from the year 1935 to 1954. The three variables in the dataset include the gross investment of firms over the years, value of the firms, and their stock of capital. The 10 firms included in the data and their coding are shown here. General Motors is coded as ID1, U.S. Steel is 2, followed by General Electric, Chrysler, Atlantic Refining, IBM, Union Oil, Westinghouse, Goodyear, and Diamond Match. The original Grunfeld data had 11 firms, but the one we are using for illustration has 10 firms as it does not include the firm American Steel. First, let us estimate the fixed effects model using the LSDV approach. In the previous tutorials, we discussed that the LSDV model is simply the OLS model, which includes the individual or time dummy variables to account for unobserved heterogeneity. Hence, we can estimate the LSDV model using the basic LM function provided by the stats package in base R and the basic regress function in Stata. We just have to include the necessary dummy variables in the model. Suppose we want to estimate the fixed effects model with individual specific dummy variables. That is, we want to control for the individual specific heterogeneity. Then, we can use the command shown here to apply the LSDV model with individual specific effects. We mention the dependent variable INV or gross investment followed by the independent variable value and capital. In addition, we also include the individual specific dummy variables using the term factor firm. Here, firm is the ID variable used to identify each firm in the Grunfeld dataset. The factor function will automatically create and include the dummy variables for each firm. Additionally, it will exclude first firm General Motors by default. This is necessary because the number of dummy variables have to be one less than the number of individual units or firms to avoid perfect multicollinearity. The data option is used to specify the Grunfeld dataset that we are using for estimation. Similarly, we can estimate this same LSDV model using regress in Stata. We mention the dependent and independent variables in the command along with the individual specific dummies. The term I.firm accomplishes the same task as the factor firm option in R. It automatically creates and includes the firm-specific dummy variables in the model. Again, the number of dummies will be one less than the total number of firms, that is, 9 dummy variables for 10 firms, and the first firm General Motors will act as the base by default. If we want, we could easily include the time-specific dummy variables in the LSDV model. The set of 2 commands shown here can be used to estimate the LSDV model with only time-specific effects in R and Stata. You will notice that instead of factor firm and I.firm, we have now included factor year and I.year. Here, year is the name of the time variable which identifies the year in the Grunfeld dataset. Hence, we included time-specific dummies in this LSDV model, but we have not included any individual specific effects. Moreover, the number of time dummies will be one less than the total time periods in the data to avoid perfect multicollinearity and the dummy variable trap. Further, we can also include both individual and time-specific effects as shown in the set of commands. Therefore, we include both factor firm and factor year in the R commands to account for individual and time-specific heterogeneity. Similarly, we mention both I.firm and I.year in Stata command to include individual as well as time-specific dummy variables. Hence, we can easily include the dummy variables and estimate the fixed effects model using the LSDV approach in R and Stata. Next, let us illustrate how we can estimate the fixed effects within model in R. Both the one-way and two-way fixed effects can be easily estimated in R. we can use the PLM function provided by the PLM package in R to estimate one-way and two-way fixed effects model. The command shown here can be used to estimate the one-way within model with individual specific effects, similar to the one we first illustrated in the LSDV approach. The results of the model will be saved in the within IND object shown in the command. First, we mention the dependent variable INV and independent variables value and capital. The data option is used to input the name of the dataset that we are using. The effect and model options provided by the PLM function are of special interest to us. The effect option is used to specify whether we want to include individual specific effects, time-specific effects, or both in the model. We specify individual if we only want to include the individual specific effects. Similarly, we can specify time to include only the time-specific effects. Finally, we have the option to specify two ways if we are estimating a two-way model to include both individual and time-specific effects in the model. In the model option, we specify within because we are interested in estimating the fixed effects within model. In addition to within, this option allows us to estimate several other models. For example, we can specify pooling for a pooled OLS model, random to estimate the random effects model, specify between for a between effects model, HT for Hausman-Taylor regression, and FD for a first difference model. Since we are estimating fixed effects within model with individual specific effects or firm-specific effects, we will specify model equals within and effect equals individual. For a two-way fixed effects model, we can simply change the specification to effect equals two ways and everything else can stay the same in the command. In Stata, we can use the xtreg function to estimate panel data models. It is also important to note that we must declare the dataset to be a panel data using the xtset command shown here. The syntax for this command is xtset followed by the ID identifier and time identifier. Therefore, we input xtset firm year in our Grunfeld example. In the xtreg command shown here, we first mention the dependent and independent variables. Then, we just have to specify the option FE at the end to estimate the fixed effects within model. This command will automatically include the individual or firm-specific effects in our example. However, to include time-specific effects, we must use the I.year term like we did in the LSDV approach. Stata does not provide the option to include time-specific fixed effects in the FE option of xtreg command. As a result, we have to include time dummies to account for the time-specific heterogeneity and estimate a two-way model. In addition to within model using the FE option, the xtreg command allows us to estimate several other models. Instead of FE, we can specify BE for a between effects model, RE for random effects model with GLS transformation, MLE for random effects with maximum likelihood, and PA for a population averaged model. Let us take a look at the results of the fixed effects models using the LSDV and within Estimator. The tables shown here represent the results of the fixed effects model with individual or firm-specific effects. The bottom table reports the coefficients and statistics from the LSDV approach, and the first table reports the results of the within Estimator. You will notice that the coefficients associated with the independent variables value and capital are the same in both models. We discussed this in previous tutorials that the beta coefficients from the LSDV and within model are the same. Moreover, the standard errors are the same for both the models as well. The difference in the results is that the LSDV model estimates some additional coefficients. The individual specific dummy variables and their coefficients are included in the table of results of the LSDV model. The coefficients of the dummy variables give us a different intercept of each firm as discussed in previous tutorials. The constant is the intercept of the first firm General Motors. To obtain the intercept of other firms, we simply add the dummy variable of that firm to the constant. The within Estimator, on the other hand, does not estimate these effects as coefficients. The interpretation of the beta coefficients is similar to that in the OLS model. With a 1 unit or 1 million increase in the value of the firm, the gross investment increases by approximately 0.11 units or 0.11 million within a firm. We mention within a firm here because we included only individual specific effects and we demeaned the variables using within transformation. This demeaning eliminated the between effects. As a result, the coefficients represent the average effect of the independent variables within firms over time. In a two-way model, this will be slightly different because we include both individual and time-specific effects. In that case, the coefficients will represent the average effect of variables within firms within a year. To obtain the fixed effects, we can use the fixf command from the PLM package in R. In the fixf command shown here, the object within IND contains the results of the within model we estimated. In this command, we also have the option to mention the effect that we want to extract. We estimated a model with firm-specific effects, so we specify effect equals individual to obtain the individual specific effects. We can specify time for time-specific effects or two ways for a sum of the individual and time effects from a two-way model. We can also choose the type of fixed effects where we have the option to specify a level, d-mean or d-first. By default, fixed effects are reported in levels or in terms of μi. If we specify d-mean, then the fixed effects are reported as deviations from the overall mean of the effects. For example, in individual specific effects, d-mean option will take the mean of all individual specific effects and subtract it from each firm's individual specific effect. That is, μi minus μ bar, as it will report the deviation from the mean. Similarly, d-first option reports the deviations from the first firm's individual specific effect. That is, it will estimate μi minus μ1 and report these deviations. Using the summary option with this fixf command gives us some additional statistics on the significance of these fixed effects. Here, we have estimated the fixed effects with d-mean option and applied the summary function. The standard errors, t and p-values show us which firm fixed effects are significantly different from the mean. In our example, most of the individual specific fixed effects are significantly different from the mean. In Stata, we can use the predict command to extract the fixed effects. After estimating the within model using xtreg, we can specify predict feu command to obtain the fixed effects of each firm. Fixed effects from this command will be the same as the fixed effects with d-mean option we used in R. Moreover, the constant reported in the Stata results is the mean of these individual specific effects, and fixed effects are the deviations from that mean or constant. Thank you for watching, and I will see you in the next tutorial.